Hello, I'm Justin Kaltenbach. I'm the CIO of Health IT Squared, and today I'm going to present on Oracle Healthcare Master Person Index, or OHMPI. A little bit about Health IT Squared. We're actually an Oracle Gold partner. We're one of the few partners of Oracle that specializes in healthcare. The history of the product actually dates back about over a dozen years now. It's gone through a couple acquisitions, and during that time, it originally started out as a product under the company STC, or CBeyond Technologies Corporation, where it went through a couple of names there, UI and E-Index. It was then acquired by Sun Microsystems, and most recently then acquired by Oracle. Today it continues at Oracle and is a strategic product. It's been brought out as a standalone when at Sun it was part of a suite. So today it continues to go strong and really provides a powerful piece of infrastructure for healthcare, or for the healthcare enterprise. At a high level, what OHMPI does is it's a master index. It creates a single unique identifier for a person, and this can be for a patient, a member, or even a provider. So we'll go ahead and get started and continue through this deck. So why do folks need an EMPI? Why do we find healthcare organizations purchasing and implementing master person indices? The biggest reason is to handle disparate data across an enterprise, and that could be across different systems, different departments, and there are many reasons why we find disparate data, anywhere from organizations that have merged and have to bring data together because it originated from different systems, or overall just different data sources within our enterprise as we have purchased systems from different vendors and they're not fully interoperable. Overall, we find a great need to do this to improve both the patient and member experience. There's nothing more frustrating that we have as a patient when we're in a healthcare setting and we don't find that those who are treating us really know the full picture of what's going on about our healthcare history and our past healthcare data. We're commonly addressing data quality issues and data ownership issues. So when organizations are sharing information, who owns it, where can it sit, who has responsibility over it and maintains it. And we also have requirements to handle governance and compliance. A lot of times this comes when organizations are sharing data with each other. So all of these types of drivers are typically what can be addressed by an enterprise master person index. So what is the root of the problem? Basically, it boils down to just a spaghetti of access points and information stores. And we see at the bottom here an example of some patient data repositories. And for most of this deck, we're actually going to refer to this as a patient index. That's what is the most common implementation of this product. So anyways, we see down at the bottom here a variety of different data sources, anywhere from our ADT and registration systems to practice management, data warehouses, and so on. Essentially, all of these different systems are assigning their own identifiers or unique IDs for the persons within their index, the patients in this case. And we have a variety of business processes that can access this information and utilize it in different ways, anywhere from clinical to billing or reporting. Really, it varies quite a bit. At the top end of that spectrum, we see the users of this data, folks accessing applications. And again, this can be not only the patient, but it also is clinicians, administrators running reports, really anybody accessing any of the data that exists across these different systems. And so what happens is we get this crisscross where we never really have an accurate picture of a patient's data across these different systems. A lot of times we're going into different applications, different GUIs, and there's never really one cohesive view of information for a particular patient, or at least that boils down to a particular patient. So if we drill into that issue and look at how identification typically takes place in some of the systems we're working with present day, they're a lot of times using a very basic or rudimentary means to match records when there's data being compared between a couple of different systems. So if we compare the top two records, we can see very easily that from the data at least, these are two different people. While they do share the same name, the address is quite different, as well as the date of birth is very different. When we compare the two records on the left, again, the same case here, even though we see it spelled differently, at the end of the day, these are very different records. And if we're just doing simple string comparisons in a software system, these two records aren't going to come up as a possible match. So we're not as concerned about those two. But where we get into some of the gray area of where systems can and cannot make a match, it's really a comparison of the bottom two records. And in this example, we see very slight variations of the records, including different spellings, different forms of the same name and address. So you see the highlights there, Ed versus Edward, and Avenue versus Ave. And the same here in date of birth, where there's a difference or a discrepancy between the two systems. And so in this case, we commonly find a match is not taking place. And this is where some algorithms can come into play to really boost the accuracy. And that's all about, or that's what an EMPI is all about, I should say. So at the end of the day, the approach for a master person index, in this case OHMPI, is to create that single source of truth that sits alongside of the data and is usable as a service by the different processes and applications that consume that data. So when we go into our portal and pull up a person's record, we can see that aggregate view because the EMPI is feeding us the identifiers, the ID numbers from those disparate sources down at the bottom. And it's doing that because it's crunched through a variety of different algorithms and normalization and standardization routines to make very accurate matches within that system, whereas before we just were not able to do that in an automated fashion. So what is OHMPI and what kind of features and services does it offer? At a high level, it's a complete architecture that snaps into an existing infrastructure. And when I say complete, I mean it's not only an application where we've got a front end, but there are GUI tools for editing it and configuring it, as well as for monitoring it. There's also tools to analyze and cleanse the data as we do our initial implementation. We also have a set of API layers that lets us plug in and more easily interact with existing applications. So I mentioned data profiling. There's a set of tools that we use to process the data, profile it, and create some statistical representations to help us better fine-tune the product towards a client's particular data set. There are standardization routines that come as part of it and can also be extended based on what we learn from profiling. So standardization examples would be dictionaries of names, common names, and the variants like Bill, Billy, and so on. There's a full set of matching algorithms. We'll talk a bit about those as we get further down into the deck. But using both probabilistic and deterministic matching processes as we do data processing. There's a deduplication process. So a workflow that handles duplicates and links them together. And also for exception handling, there's a graphical user interface for a data steward or a medical records clerk to examine data and examine reports where there are potential matches and to link those together or not. And that falls into data stewardship as well. So being able to process that workflow as well as just have an overall management for our index and the data that's in it. So at a high-level architecture, we want to quickly discover how OHMPI interacts with an existing environment. So in this case, we're representing a clinical setting. We've got a variety of different systems here, from hospital systems, pharmacy, lab, different departmental systems there. And we interact with the product typically through an integration or SOA or enterprise service bus type of layer. And there are three primary APIs which are highlighted in the box that OHMPI publishes. And this is actually common to virtually all of the products in the market. Web services, Java APIs, as well as IHE profiles, which are SOAP-style messages, but also within there is some embedded HL7 support. And HL7 is a standard commonly used for exchanging clinical data. So that's EMPI or OHMPI specifically, but where does an EMPI fit into an overall network infrastructure for some of the common projects we see in healthcare? And today, some of the larger enterprise projects we're seeing are beyond just the four walls of a particular hospital, sharing data in between their different clinical systems, but it actually expands out to networks in the form of health information exchanges, as well as accountable care organizations or ACOs. And so you look at the common architecture that's out there, and we've created a representation here that we feel covers the common components and necessary components to establish an HIE or an ACO. And this actually represents an infrastructure that Health IT Squared has developed as well as used Oracle and its products in order to accomplish. So at a high level, we see, scattered around these different players, different stakeholders within a network, anywhere from hospitals to ancillary services, radiology labs, employers, public health organizations, and so on. And at the base of that, we've got this adapter and interoperability layer to where we connect in a secure fashion and exchange data, really unlock those systems and the data that's within to be able to be shared with this HIE or ACO network. We layer in an enterprise service bus to process these messages, do transformations, route them, have exception handling when messages don't meet certain specs that we identify. We add the EMPI at this point, and I'm just sort of building up in the middle here. So the enterprise master person index now says, okay, we've got data flowing in between different systems and participants. How do we identify patients and providers, members, payers, however we want to slice them? How do we identify them across this infrastructure? So the EMPI creates that unique identification for those different patients and providers throughout that infrastructure. We layer in now identity management. So we've given access to this data, or I should say we've gained access to this data. How do we control who has access to it and who's entitled, who's not, or maybe in certain settings, we provide emergency access based on rules. We have a record locator service as part of this, and the record locator supports a federated infrastructure, a federated data model, where in this exchange, data is actually kept at the outskirts or the different endpoints, meaning it's not all pushed into a central repository. So a record locator service allows us to do a lookup in our health information exchange, discover where records are for a particular patient, and then go ahead and query those locations. So now we can discover data or really information about them by only going to the sources that have that information. It really optimizes how an infrastructure works, because if we didn't have a record locator service, we'd have to ping all 30 participants that you see here on the screen just to find data on a particular patient, when a majority of them may not even have any. And then the top layer there is about coordination, talks about coordination of care. And really that ties into the ACO model of just providing software services in this infrastructure that allows data to be shared between participants and really allows different stakeholders to be able to, while they share this data, have a complete view of the information and share it in between these different organizations. So instead of having just everybody do their own thing, what the approach is today is to be able to share information and have almost a care team or a virtual care team with access to all the same data. The top layer that we place on this infrastructure is the portal or application layer or presentation layer. This can be a mix of both clinical applications as well as analytical applications. It really depends on the consumer of that data to determine what kind of access they may have. So a governmental group or a public health group may have access to a certain data set or de-identified data, but that access is actually used to drive clinical analytics. So we can discover certain trends about our population and look at things like performance for different organizations to help determine what is working in healthcare, what's not working, where we can make improvements, how we can cut costs. Additionally, we have clinical users like clinicians, doctors, nurses, who may want to view a patient's data and see an aggregated view to recognize trends, maybe seeing a combined set of lab results that's happened over the last year as they've been in and out of different hospitals. The patient themselves may want to see an aggregated view in the form of a personal health record or patient health record, and that's so they can go to their next specialist or a new specialist and share a list of the recent medications they've been on and other treatments, diagnoses that have taken place. So as we can see, we've gone through all these different layers and these building blocks of a health information exchange or accountable care organization. Again, EMPI really becomes a crucial piece to this infrastructure because without it, we cannot really link records together in between all of these different data sources. So at a high level, let's talk about some of the features and benefits you find within OHMPI or the Oracle Healthcare Master Person Index. First and foremost, it serves as a cross-reference of information, meaning we're creating linkages and associations of records across disparate systems, and we do this through both probabilistic and deterministic matching. OHMPI can leverage existing identifiers, so we don't really need to alter or change how an existing source system works today. It comes with a full graphical user interface for configuring the product. So when we want to adjust what the data structure looks like, what fields are in OHMPI, we can do that very simply by right-clicking and adding a new field. Or if we just say maybe we're adjusting the weights and ranks and how the algorithms generate scores, it's all, again, a graphical model to do that. The product is highly scalable. It's built on an application server architecture, so there are implementations with records in the hundreds of thousands all the way up to the hundreds of millions, and they can all respond with sub-second times. Really, the goal here is to have this as a key piece of infrastructure, but not really to impact how users are performing today. So a lot of times users aren't even aware that an EMPI is in place because it can respond so quickly. Their applications look and feel just the same as if it wasn't there. Cleansing, data standardization is all part of this. So it'll validate data automatically by looking at data types and structures, formats. There are normalization routines, as I talked about earlier, for standardizing, normalizing things like name and address. Potential duplicate workflow is a huge part of the product. And a client can even fine-tune how loose or tight their rules and thresholds are when going through data processing, and that will determine what kind of records end up in a potential duplicate queue to be worked by a data quality manager or a health information manager, medical records clerk, whatever title we want to call them. Access to the system is provided not only through that GUI where we can query records and do lookups, those sorts of things, but also through an API layer. And again, we talked about these as being web services, Java APIs, as well as IHE profiles, which are SOAP services. So let's talk about the matching process now. How does it work? What happens when a record comes into the system? And we're going to give an example in this case of a couple approaches or a couple methods that records can come in. And they really both behave the same way. So those two methods are whether someone's just querying the EMPI, meaning they're in some sort of application and they're doing a search for a patient. The other is if we have an inbound record coming, and a lot of times this is coming from an ADT process or a registration process in one of the systems tied to the EMPI. So in this case, we're just going to go in the scenario of a query where a user's in some application and they do a lookup, and in turn that's going to query the index, and we'll say that's record number 1. So they've entered this data on a form. They put in EDLI, and maybe it was a user ID or some sort of identifier, ELI, and they put an address of 1 Serrano Avenue. So that's record number 1. And so what's going to happen is a two-step matching process in OHMPI. And the two-step process essentially is broken into two parts too. It's broken that way to optimize how the query takes place in the system, because we've got to go from this query, this inbound query, which is record number 1, and maybe compare it against a million or, again, tens, hundreds of millions of records. And so it's too resource intensive to do a deep comparison with all the algorithms from this one record against, a million or 10 million, whatever it may be. So the two-step process actually starts out with a very simplified loose candidate search. And so it may say, give me all the records where the name is Ed Lee, first name Ed, last name Lee. And that can net 5 results, and let's just say we put those into a bucket. The next query will say, give me a match where I have Ed at 1 Serrano Avenue, any Ed at 1 Serrano Avenue. Let's say that gives us 3 records, and we throw those 3 in a bucket. And then the others may say, give me a list of patients or bring me back matches where we've got a match on date of birth, gender, and last name. And so, that nets 4 records. We throw those in the bucket. So we go through several different query iterations where we're just matching on maybe 1 or 2 fields, a very minimal set in each of those. But at the end of that first step of the process, we've now got a subset of records that match our query in some respect or another. And so now we've narrowed down from index of 1 million to a much more manageable number that could be in the tens or, let's say, below 100. So now we move to step 2. And in step 2 is where we do a field-by-field comparison, which each of those fields then is using the various algorithms and comparators to make a very calculated comparison in between the 2 records. So we're going to use record number 2 here in our example as one of the few in our subset. So let's see what that looks like. So as we compare these 2 records in a field-by-field fashion, you'll see here the weighted bar in the center is where we generate a score. And each of these fields is going to have a variety of comparators that are computing based on the data that we know are in those fields. So for example, in first name, a few things are happening. One, we're going through phonetic engine, but we're also going through a dictionary match to, in this case, recognize that Ed and Edward are different forms of the same name. So In this case, we're going to, let's say, it's going to give it a score of 9.2 out of 10. We next go to last name, in this case, Lee and Lee. We have an exact match, so it gave it, in this case, a 6. Why is that less? Well, last name, in this case, has a frequency analysis done on it, and in our index, we recognize Lee as a very common name. So what it's done is actually discounted a match on Lee to some degree, because we know that there's a higher likelihood of match with that kind of a name. It's less statistically significant. For example, my last name of Kaltenbach is typically a fairly unique name when you go into a phone book or an index like this. So in that case, it would make a match on Kaltenbach and give it a bit of a higher score. It's more statistically significant. We have user ID, and this really represents any form of identification or ID number, alternate ID that may be out there. So here it's just doing a common string comparison, comes up with a score of 9. And now we get to address. And address is actually an interesting one, because address we break apart into 4 subcomponents, at least in the United States. And the product is actually localized for a variety of countries, so we can handle addresses in the UK, Singapore, Australia, various countries in South America, Central America. So it's been adapted to many different locales. Anywho, here in the U.S., like I said, we break it apart into 4 subcomponents. We're only showing 3 of the 4 as part of the data here. So we have the street number, the street name, the street type, which is avenue, and then the last piece is the street direction, which only exists in certain locations in the U.S., and that would be like a northwest, the southwest. Usually it's a bit shorter. So by tokenizing this address, by breaking it apart into essentially subfields, we can actually do a standardization routine automatically in the index, which will compare each of these parts of the field independently and recognize similarity. So in this case, we see 1 as ONE as well as the number 1, and those routines are going to recognize those as the same thing. Same with Serrano, and we can even apply a phonetic maybe on the street name. In this case, it's an exact match, so there's no need. And then you get to the street type, avenue in this case. And again, our routines in OHMPI recognize that these are different forms of the street type. It could be AV period, AVE period, different case, avenue spelled all the way out. Regardless, we recognize that component of the address line 1 is the same. So the weight for that field and match there is 12.5. Now, we add all that up, we get a overall score of 36.7. So what do we do with that? We now look at that number 36.7 on a threshold scale. We have 2 thresholds that we define in OHMPI, a high threshold and a low. And when records or a pair of records that are compared are above the high threshold, what we're saying is, hey, there's so much data in common that we're going to consider these an automatic match, that we link them together automatically. On the opposite end of that, below the low threshold, we're saying that there are so few fields in common, or there's so little data in common, that these are 2 different people. We're saying that record number 1 is actually a new record to the index, meaning there's nothing like it, it hasn't seen it before. In between that, we've got the area of a potential match or a potential duplicate. And what OHMPI does when a record falls in between those 2 thresholds is it actually flags them as a potential match and puts it into a queue for a user to examine. So we'll get into that a little bit further, and actually in a subsequent presentation, I'm going to demonstrate what that workflow looks like right within the product, so you can get a feel of how potential duplicates are handled and how we resolve them, what the screens look like, how we compare the 2 records and make that decision, should we link them together or keep them as separate records. And what I will note is that potential matches actually represent a very small percentile of records processed within the index. It's quite common that it's really just a small percent or fraction of records that end up in that queue area. So to recap some of the matching concepts that we talked about, the probabilistic or fuzzy matching, what's going on there? So we've got a variety of different ways that we can compare values and assign a weight to them. One is just a very simple character by character comparison, but most commonly we're actually going into several different levels of character uncertainty. And that is we look for phonetic errors, transposed digits or characters, even transposed fields. So first and last name being put into incorrect fields. And we see that one. Sometimes last names are similar to first names. Character insertion, meaning there's an extra character that doesn't belong there. Deleted characters, hey, we're missing something. And replace characters. And that's kind of common when we see characters, well, it could be a mistype, but we also see it when records are come from a handwritten form and are input into a computer. So they're not able to read someone's handwriting very easily, and because of that, someone has keyed incorrectly. When we talk about names, there are many things that occur in the product. We handle aliases in a couple of different ways. We've got dictionaries for common nicknames, so John, Johnny, Jonathan, John spelled a couple different ways. But we can also handle aliasing for nicknames as an example. So we could say my name is Justin, but my friends have called me Chuck ever since college. So that would be an alias. Obviously, a dictionary is not going to associate Justin and Chuck, so we would add that in as an alias, almost like a special nickname for that particular person. When we get into phonetic matching, we apply different algorithms to different fields. So first, middle, and last all have different algorithms, and commonly we're using sound exonesis or variants thereof. And sound exonesis are a nice base that have been incorporated in the product for some time, but we've gone and Oracle has gone and improved these over time and really made them much more powerful as they've been incorporated through this product over those years. We can also do some filtering, and by default we filter out certain values that we can commonly expect in healthcare, for example, baby boy and baby girl, or sometimes we've got, let's say, a social security field that's required in a registration system, but we're not required to collect that, and a lot of times we don't because of regulations. So someone still enters 99999, and so what we want to do is make sure that we're not matching records just because the social is 99999. So when we do our initial profiling and analysis, we can recognize problematic values such as the null nines and go ahead and put in the filters to catch those and remove those fields from being calculated when we're comparing records. And that really is done specifically at a record level versus a global level. Lastly, we also talked about how we tokenize the address. And that's important because we can see here, again, another example of the exact same address represented two different ways. And again, we can apply phonetics on just about any field. So in some cases, we will do that on the street names as well as the cities. So what does the enterprise structure look like? What does a record look like in OHMPI? And really, we're going to show the hierarchy in this particular slide, starting with the enterprise record at the top. So enterprise record means this is what a record looks like representing one person. And again, that could be a provider, it could be a patient, it could be in the member category if we're looking in the pair space. And really, it boils down to these arrows that are underneath. So the single best record is actually a hybrid view of that patient's data as it's come from the different source systems. And in the case of conflicts, there's actually a set of survivorship rules that'll execute to decide, hey, if one system says the name's Justin, the other says it's Justine, which does it take? So the survivorship rules in OHMPI will help it determine which to take in that conflict example. So it could be something like, hey, source system A is more reliable for names, so we want to use that. Or it could say something like, you know, there's a record in system B that's more recent, we want to take that one. So below that single best record or that golden record, hybrid record, whatever we want to call it, we've got the links then to the various system records. So you see system A and system B listed there. And then you also note that system B is listed twice. So we can actually handle duplicates from the same system. There's really no limitation to the number of source systems we connect to, as well as the number of records from a particular source system that a patient may have. So a patient could literally have 20 different records within, you know, a Cerner or an Epic, and the OHMPI would be able to recognize that all 20 of those records really boil down to being the same person. So data stewardship, we talked about this a few moments ago. Now what we represent here is a screenshot from OHMPI, because in a subsequent presentation we'll actually do the live demo. So data stewardship is all about how we access, monitor, and maintain the data within OHMPI. And it's a browser-based application, so it's very simple to get into. We can log in, and we're provided a menu. You can see the different buttons or tabs there across the top. It's fully role-based access, so users can have, or there are user controls over what they have access to, even down to what they can see or what fields they can search by. So a user with minimal privileges may only be able to search by a patient's medical record number, whereas a user with wider privileges can maybe search by first and last name. So there's a lot of controls built in, functions for reporting, functions for just searching, the ability to process potential duplicates, the ability to look at a transaction log and see what changes have taken place to a patient's record over time. So we can see historical snapshots and, oh, okay, here's when they may have had an address change or added a new phone number, or they got married 2 years ago and their last name changed, so we can see what when the maiden name was switched and put in a new last name. So everything that's tracked about the data is accessible through this GUI, which makes it nice because some of the products out there that don't have a very strong GUI really only provide an API layer, and you have to end up writing your own custom software to just access that information in the index. Scalability is a big part of OHMPI, and it's been designed really from its initial get-go over a decade ago to even today to be a scalable product, and even to the point where it can grow with organizations. So it's both horizontally and vertically scalable, supporting features in both the application server as well as the database, which can be either Oracle database, MySQL, or Microsoft SQL. So supporting the scalability features in the database as well as the application server, as I was saying. So organizations don't have to worry about outgrowing the size of their implementation. It can be as easy as adding additional hardware to an existing implementation of the product. I want to talk briefly about the provider index because there are some interesting aspects to make a point of, since a lot of this deck we've talked about the patient aspect. So with the provider index solution that comes with OHMPI, one of the nice features is that it supports in the same data model both individual providers as well as organizations, and the ability to then manage these views and entities separately. So you may have a provider who belongs to multiple organizations, and you may have vice versa, an organization with multiple providers. So one of the nice features, again, is that we can keep in the same data model representations of both of these. The provider-specific data model has fields that incorporate standards in the U.S. as well as Australia and other countries. So, for example, in the U.S., the National Provider ID is one of the most recent identifiers that has come about. Presently, providers are moving or transitioning to using an NPI, but they may already have 5, 6 different IDs that they're using, including a tax ID, a license, a UPIN, a Medicaid, a Medicare number, a CCN, NPI, and it keeps going on and on and on. So at the end of the day, there are quite a few identifiers out there, at least in the U.S., for providers. It's built with IHE standards and best practices that come from within the health information exchange industry. So it's really ready to fit into a variety of different infrastructures. And just like the patient model and member model, there are out-of-the-box configurations already defined in there for how it standardizes, phoneticizes, matches, what fields it's using, what thresholds are there. So quickly, a brief representation of data, and if you look at the records on the record on the bottom left part of the slide, it looks pretty busy. But really what that's just representing is the data that can potentially be in the index as it's come from a lot of these different source systems. And those source systems, in this case, represent on the top part of the screen. So there's maybe credentialing, billing, and a clinical system here. And as they're indexed, basically we have that single best record which gets created, and that single best record will have that hybrid view of information. So part of that provider record also ties in all those different local ID numbers from those different source systems. So at the end of the day, we've got an enterprise ID number, which on the left is highlighted in red as unique ID, which ends in 4101. And underneath that, it's tying together the local system records, which you see the 3 there, the HA, the PED, and the 76 number there. So some success stories. Where has OHMPI been deployed, and some examples of how this product has done some real benefit for healthcare organizations worldwide. One example is the the UK National Healthcare System, and this has been a very long time running client of the product, and essentially one of the most strictest when it comes to the service level agreements. And you can see down in the bottom portion of the list here, or the bullet list, query in 0.2 seconds, update in less than a second, and having a volume of transactions per second of 400. So we have consistently been able to meet those requirements, and doing that for an index processing over 50 million patients for the entire UK. So the classic story of how this is utilized across different organizations is a patient can go from one facility to another. Let's say they are from Bristol and they're on vacation in Newcastle. What do we do when they end up in a hospital in Newcastle and there's a need to see the patient's data and view a summary record to understand, the crucial things? What medications are they on? Have there been any recent visits? That jumped ahead of me there. Have there been any recent visits? And, again, the idea is to get crucial data in order to treat this patient in the case of an emergency. So they can query the master index, see where records exist from the rest of the spine, as they call it, and be able to pull in that summary record, which is stored alongside the EMPI. Next example here, Relay Health or McKesson. It actually serves the clearinghouse for Relay Health, and you can see just an example of some of the transactions that are processed per day in the tens of millions, as well as the sheer volume of records in that database. In this case, we've got approximately 2/3 to 3/4 of the U.S. population by now indexed in that product. And it's deployed over a large number of application servers, as well as a Oracle RAC cluster to support that scalability. So this is a great example of how the product has scaled to quite large numbers and volumes. Another one here, very long-term customer of the product, New York Presbyterian Health System. They've got just about every flavor of application out there, Epic, Cerner, McKesson, IDX, and so on and on and on, over 70 systems in their enterprise. And OHMPI serves as the master index for these systems, meaning it is the single source of truth for unique identification. And they're probably over 10 million patient records by this point. Again, the numbers here are very, very impressive for being able to support all of these different systems at all these different locations. Let's talk briefly about some technical details. What I want to do now is peel back the layers on some of these components within the product and give you an understanding of what's there. So the design time environment is actually based in the NetBeans tools for configuration. And like I mentioned earlier, it is a graphical configuration mode, and we'll demonstrate this in a subsequent presentation. There are different wizards for configuring and defining. Ultimately, it'll generate internally a set of configuration files, which are then used to both generate a database script or a set of database scripts to run on your database of choice, as well as it'll generate a couple of applications that are deployed to an application server. And the enterprise application is what handles a majority of the processing and APIs, etc., as well as the web application, which is there to provide the user interface for users to interact. And again, that's for Master Index Data Manager. So on the right-hand side, you see runtime. That actually shows the runtime components which go on the application server. So the web container, again, is just the web application, but that's interacting with all the same services you have below in the enterprise application. So in here, we can look at the breakdown and see some of the different processes that run and control the data as it's processed, whether it's a query or an inbound record being persisted, such as a registration message. You'll also see it's interacting with the database. So as records are updated or added, those are being persisted to a database of choice. And on the bottom right there, you see the event repository. So anytime there's an update, a change, a linkage, such as a merge or an unmerge, anytime there's a change in OHMPI, it's publishing messages to that event repository. And that's useful because in some cases we want downstream systems within our enterprise to be aware of these changes that have taken place in OHMPI. A quick look at data profiling and cleansing, and these are processes typically done more up front during the implementation phases. So data profiling starts with taking our raw data sources and running them through the profiling engine that is embedded or comes with OHMPI, and it generates reports. It gives us information about our data that is not necessarily obvious until we run a process or report against the entire or a large portion of our data set. So from there, we get things like reports on statistics on the data, such as what are the numbers of records. We also have the example like frequency analysis. What are some of the common values in our data that we may want to put rules or filters or exceptions in? What are some of the fields that tend to have junk data? What are some of the junk values where we maybe want to go to the source systems and clean up that data, or maybe put in a rule to filter that out so it doesn't make it into OHMPI? And then that goes next into the data cleansing. So as a result of profiling, we may put in some rules in place, and then before we load it into the master index, we have to go through some routines to clean it up, make sure that it meets the stringent requirements in order to put it in OHMPI. So it'll go through some various validations and mappings and then routines to ultimately pre-populate the OHMPI database. And the result of that cleansing phase is a good file and a reject file. The good files are obviously loaded, and then the reject allows us to do additional work and reprocess it. So a couple key points as we near the end of this presentation. So what is the threshold methodology that we discussed, and why is there two thresholds? To really understand that, we first look at an example where there's one threshold. So we're showing here on this slide a representation of two bell curves, and those represent records that do not match and do match when you're comparing a query of one record against the index. So we've got a query of Justin Kaltenbach going against OHMPI, and there's going to be a very large curve of records that match in varying degrees, and there's going to be a slightly smaller bell curve of records that do match in varying degrees. And that match curve is actually going to be a bit smaller, but it's enlarged for emphasis in this case. So if we just drew a line down the middle and said, okay, if we're above a certain score, we make a match, and we're below, we don't make a match, what happens is you create two areas of statistical error: type 1 errors and type 2 errors, which are basically false positives and false negatives and false positives. Instead, what we do in OHMPI is we put in two thresholds, a high and a low. And essentially what you can see here is we've now replaced that area of statistical error with a manual review phase, or a manual review process. So in the event that we had a record that fell in between those two thresholds, it's where we're essentially saying, you know what, the system is not able to accurately make a decision of whether or not these should be linked together or not. And so that manual review allows a data steward, or someone who is more familiar with the data and the environment, to look at these records, maybe do some additional investigation, and decide whether or not they should be linked together. Couple last slides here. Configuration in NetBeans. So a look at what that config GUI offers, and you see on the left-hand side a structure of the data as it exists in OHMPI. We can add or remove fields very easily. On the right-hand side, we can see some of the config options for the fields and what the values are that are fed into the algorithms for when there is a match versus when there's not a match. And we'll actually dive into this a lot deeper in our next presentation, which is a demonstration of the GUI and configuration environment. Lastly, one of the things to cover here is the implementation mode. Now, so far, we haven't really discussed any of this, but the product can be implemented in a couple of different ways. And really the first way that OHMPI is typically implemented is in what we call a passive mode, and the second phase of that, or second step, would be to go to an active mode. So what we're actually simulating on these different boxes here is a typical workflow that's encountered for a registration clerk, and they may be at a hospital and using a legacy system like an Epic or a Cerner or anything else for that matter. And so that passive approach looks something like this. The user logs in. They have to do a registration for records. So they first search. They enter their criteria. They see a list of results there that may be matched in some degree or another. And at that point, at screen 5, they have to decide, okay, do I select one of these and do any updates if necessary, like there's a new address? Or do I just create a new record, meaning they didn't look like anybody in my search results, so I'm going to add them as a new. Then they may enter a little bit more information and enter some insurance data, and again, continue on their way. Now, the big issue here is if there was a mistake made during screen 5, let's say they decided, oh, I'm just going to add a new record because it didn't look like anything, or maybe I'm just lazy. We've inserted a duplicate into the system, and the EMPI would have caught that, but it could have maybe flagged it in a potential duplicate queue if there wasn't enough to make an automatic match. So that creates a workflow task, and then obviously someone in medical records has to process it at some point. But what makes it passive is that could be processed an hour after creation, a day after, a week, a month, a year. It basically means when there's a potential duplicate, it's processed at some point in the future. Now, active implementation basically eliminates that step by altering the workflow and essentially empowering our users of these legacy systems to have more information and a more interactive workflow than what is commonly there. Now, the difficulty with going to an active implementation of an EMPI is that it requires some sort of customization or integration with an existing or legacy system. And so that can sometimes be tricky, or at least it requires some additional or custom work. And so what we're actually doing with an active implementation is altering the workflow to leverage the EMPI versus just the classic search routines that were in that application. So the workflow in this case looks something like the user signs on, they do an initial search and look up for a particular patient. And at this point, instead of just querying the internal database, which an application is designed to do, we intercept that and we redirect them to a screen that's provided by OHMPI. And so instead, they're presented with results from the master person index, and they're given the view of different fields, maybe some more fields than they would have normally been given. But most importantly, what we're doing is a very detailed and weighted comparison of what the user is entering versus what's in the master index, when a legacy system is not going to go anywhere near those levels of checking and duplicate processing. So what can happen now in this augmented workflow is we can say to the registration clerk, hey, it looks like what you've entered, there's a couple records here with a 95 or greater percentile chance of match. Are you sure you want to add this patient in as a new record? If so, you may be flagged for an audit. So we're altering the workflow. We're making a registration or a user more aware of the introduction of a duplicate record and allowing them to review the data and maybe instead say, oh, wait, you know what? I think this is your old address on one of these records. Let me pull it up. Oh, it is you. And, let's update your address. So we've augmented that workflow to allow a user to make a more informed decision. And we've also augmented that workflow so they don't just go ahead and perform the same old practices that they've done in the past, which were just to always introduce duplicate records or always put a patient as a new patient in the system. So once we go through this new workflow that we've introduced, and the registration person has selected the correct record, we put them back into their legacy application or their existing application, and then let them continue on their normal workflow. So again, it's all about augmenting and preventing that duplicate from being added in real time versus letting the OHMPI catch it and having someone fix it at some point in the future. Well, at this point, we've concluded our presentation, and I'd like to thank you for watching and listening. If you have any questions or are interested in maybe a live demonstration of OHMPI, please feel free to contact me. My information here on the screen. Again, Health IT Squared is an Oracle Gold partner who specializes in healthcare and healthcare infrastructure. And we've got a set of technologies that are our own as well as Oracle technologies that can really deliver an end-to-end infrastructure for a variety of healthcare settings. So we encourage you to reach out to us at any time with questions. Thank you very much.